So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. So today's question is allocate minimum number of pages, and it is also a very beautiful question, just similar to aggressive cows. So what is actually happening is you have been given an array and you haven't given a k. Let me tell you what does this both simplify. So array simplifies books. That is, you have one, two, three, four books. You have four books. So book number 1 contains 12 pages. Book number 2 contains 34 pages. Book number 3 contains 67 pages and book number 4 contains 90 pages. And K represents number of students. So here you have two students, right? So it is quite inducible that books have to be distributed amongst the students. Books have to be distributed amongst the students. So distribution. But for this distribution, there are some rules. Let us now note them down. So each student should have at least one book. Each student should have at least one book. This is the main compulsion. Second compulsion is that suppose a student is taking two books. A student is taking two books, or three books, or four books, or five books, or any books, any number of books. So he has to take in contiguous fashion. That is, he can take 12 and 34. He cannot choose 12 and 67. He will have to take 34 also if he's choosing three of them. Right? You have to choose in contiguous fashion. That is, student can take more than one book, but in contiguous manner. Right? And all books have to be distributed. All books have to be distributed. You cannot say that I'm not distributing some amount of books. You will have to distribute all the books. This all the four books have to be distributed among two students. You can do 3 1 1 3 2 2 any kind. 0 4 is not possible. Sorry. These are the three configurations, right? Okay. Now, how will you proceed? How will you proceed? Okay, sorry, I didn't mention what is asked. So, for the given question, that is 12, 34, 67, 90. Suppose I say that I am allocating, like I have student 1 here and student 2 here. I am allocating 3 books to this student and one remaining book to this student. So what is actually happening? So if we count the page numbers, so how many page number is this student getting? So it is getting 12 plus 34 plus 67, and the remaining pages are 90. It is getting. What is the sum of 12, 34, 36, 67? So if I sum them up, it is 2 plus 4, 6 plus 7, 13. 1 is a carry, 1, 2, 5, 11. So he is getting 113 pages. He is getting 90 pages. Which is the minimum among these two? Among 113 and 90? So among 113 and 90, 90 is the minimum. 90 is the minimum. And what is the maximum? 113. 113 is the maximum. You have to minimize this maximum value. Minimize the maximum value. So let me state it down very clearly that what is question asking. Question is guiding you to find a configuration such as here it was 1 3, right? Similarly 3 1 2 2 is also possible. Question is guiding you to find a configuration in which maximum pages received by any student received by any student is minimum, right? And now for this you have to return this minimum value. Minimum value should be returned. problem with this type of question is that the problem statement is very confusing. So you don't know what to do, right? You don't understand what is the question asking you. So that is why you are not able to construct an algorithm. Otherwise, this question is very easy, right? Now, I think we are clear on the part that what we have to provide them, right? Now, suppose I have an array 12, 34, 67, and I am given k equals to 5. Can you answer? What will be the answer here? Can you give me a specific answer that what will be the answer here? You will say that the first condition was that each student should get at least one book, at least one book. And because the size of the array is less than number of students, it is nowhere possible that I can allocate each student at least one book. So I will say no configuration. That is no answer. And whenever you are returning a no answer, you will have to return -1. That it is not possible. -1 for not possible, right? Okay. For the cases where it is possible, such that this case 12, 34, 67, 90, and k equals to 2. How we will solve for this one? Okay. So let us go by brute force. Let us go by brute force. Optimize it बाद में. Let us go by brute force. What will I do? I will simply say that the lowest number of pages that I can allocate is 0. 0 is not possible because I have to allocate at least one book. But I am saying in an ideal case, this is an ideal case. Lowest number of pages I can allocate is 0. What is the highest number? Now suppose if your k would have been equals to 1, then for the highest number you will have to add them up 12 plus 34 plus 67 plus 90. So your high equals to sum of all values, which is equals to 113 plus 90, which is equals to 203, right? So I am saying your answer can go from any value from 0 up till 203. Any value from 0 up till 203. You have to choose a minimum value which is possible. Minimum value which is possible for given array for ARR and K, right? How will we find them? So I'm saying from 0, that is 1 is also possible, 2 is also possible, 3 is also possible, up till 201 is also possible, 202 is also possible, and 203 is also possible. Now tell me, because I need to find the minimum value, can I say, if I will say 0 is possible, 1 is possible, 2 is possible, 3 is possible, as if I say that these 3 were not possible and this 3 was possible. If I say 3 was possible, can I say that this is the minimum value for my answer? And hence it is my answer. Just as we did previously for the aggressive curves. Because we need to maximize the answer, we started from the right. But here we need to minimize the answer, so we started from the left. And as soon as we get an answer, we will say this is true. Because if 3 is the minimum answer possible, then it is true for 4, 5, 6, 7 also, right? Okay. Now, how to solve this? How to solve this? So, suppose I'm checking if let's say 90 is a correct answer or not. 90 is the correct answer or not. If I'm checking for 90, what will happen? I have the array that is 12, 34, 67, 90. Now, what I'm trying to say is I'm checking for 90. What do I mean by that? I am saying minimum value, minimum value for maximum pages a student can have. Maximum pages a student can have. So what will happen? I will say I have two students. Student number one, student number two. This is my student number one, this is my student number two. Both of them have currently 0 pages allocated to them, right? Both of them have allocated 0 number of pages. I want to allocate all the books. So I'm standing at 12. I'm standing at 12. I will say that I will do the allocation for first student and I have to do it contiguously. I will say that I cannot go more than 70. I cannot go more than 70. Cannot go more than 70 because I've chosen my maximum value as 90. Sorry, I cannot go more than 90 because I've chosen my maximum value as 90. More than 90. right? So I come to 12. I say, see, if I add 12 to this existing 0, it will change to 12, which is still less than 90. So I will allocate this to number 1. I come here. I say 12 plus 34 will give rise to 36, 46. Again less than 90. Done. As soon as I go to 67, that is, this is also allocated by 1. This is also allocated by 1. 67, that is 46 plus 67. 6 plus 7 gives me 3. And it is a 113 answer we have already calculated. You will say that 113 is a value greater than 90. So if I allocate this book to 1 as well, he will get 113 pages. And I have a maximum limit of 90, so I cannot give it to him, right? You will say, okay, now here comes my second student. So you will say, okay, I will allocate this to second. That is 0 will change to 67. Okay. I come here. 67 plus 90. 67 plus 90. Which will give rise to 157, which is again greater than 90. So you two will say, see, I have reached my maximum limit. I cannot go beyond 90. So I will not take the this fourth book. Okay, you will say, okay. Let us assume there is a temporary third student. As soon as it will reach 90, we will say, I will take the 90. So if you see, you required one student, two student, three student to catch the value of 90. You required three students for value of 90. For value of 90. But in actual, you had only two students. So you will say, see, because I was not able to do it within the two students, I will return false. I will return false. Okay, understood. Now, suppose if there were, if only first would have gone, like if the array would have been something like this: 12, 34, 1, 2. I had two students. I'm choosing the value of 90. What would happen in this case? Both of them are 0, 0. It comes here. It says 0 plus 12 gives me 12, less than 90, allocate it to 1. Comes here, again less than 90, 46 again less than 90, allocate it to 1. Comes here, again 47 will be less than 90. Comes here, 49 will be less than 90. So what should my function return? Should it return true or should it return false? Tell me. What should my function return? Should it return true or should it return false? I am going to say it will return true. Why? You will say, see, you have not obeyed the condition of each student getting at least one. You have not obeyed the condition of each student getting at least one. I will say, I wanted my maximum value to be less than equals to 90. I am saying my 90 is my maximum value possible. Maximum value possible. Is that being obeyed? Yes. Then you will say, but it is still not getting a book, right? It is still not getting a book. So what I want to say is, if it is not getting a book, what I will do is, like you can see, what will I do? I will say 12 plus 34 here and 1 plus 2 here. Now both of them are getting two books. He is getting 46 pages, he is getting 3 pages. And the value, that is maximum value possible, is should be less than 90 is again possible. But it is not a perfect answer. I agree to it. But it is this value is feasible. This value is feasible. If I want this answer, it can be true, right? But I want the minimum answer. It is not the minimum answer, but this value is also correct for this configuration. Now, how to find the correct answer? How to find the correct answer? So I already said that my answer will go from 0 till sum, and I will start from this side. The first value which returns true is gonna be my answer. But that will be the minimum value. But the problem is that we are taking time of O of sum, and because of the all the processing again and again and again and again, because we are taking O of n time again and again, it is O of sum into n, which is evidently O of n square, not optimized. It is greater than O of n square. It is greater than O of n square, right? It is not good value, right? I want something better. I want something better. So what will I do? O of, sorry, my lowest value was possible was 0. My highest value possible was 203. Any value between this, that is 0, 1, 2, 3, up till 202 could have occurred, right? Could have occurred. So what I'm going to say is, This is a sorted order. I have to pick a value from this to this. Now tell me a thing. Just tell me a thing. If suppose I am saying that if what is 203 by 2? It is equals to 101, right? In integer division. If I am saying 101 can be a value such that maximum number of pages given to a student is less than equals to 101. What I'm trying to say is maximum number of pages given to a student is less than equals to 101. That means if 101 is possible, it is a potential answer first of all. And because 101 is possible, that means 102 is also going to be possible. 103 is also going to be possible. What I'm trying to say is if they are able to follow the maximum parameter of 101, if they are able to follow 101, this is automatically saying they are less than equals to 102. If a number a is less than equals to 101, can I say a is also less than equals to 102? Or I can remove the equality sign also. A is less than 102, a is less than 103. That means if 101 is done, its right partition is done. I have to check in the left partition. So I can say high equals to mid minus 1. And similarly, if 101 is not done, that means if 101 is not done, that means I want more pages. That means low equals to mid plus 1. As simple as that. So the problem of O of sum into n has actually reduced to O of log sum into n, which is evidently O of n log n. Binary search contributed this log n. As simple as that. I hope you were able to understand. Let us just quickly wrap up the code and then end the video. So here we are in the coding section, but before starting, it's my sincere request to please subscribe to the channel. Please subscribe to the channel. Alright, so what will I do? Int low equals to 0, high equals to 0, and I will just calculate the sum into the high. So for auto it in ARR, high plus equals to it. So high contains my sum. High contains my sum. Now my int answer equals to minus 1. While my low is less than equals to a standard binary search procedure, int mid equals to low plus high by 2 if check for the particular configuration, that is ARR k mid. If this is returning true, then my potential answer is mid. And because the potential answer is mid, that is 101 is my answer. That means 102, 103 are automatically feasible answers, but I want the minimum. So I will say high equals to mid minus 1. Else, if 101 is not the answer, then check for the greater values, because if 101 is not possible, then 100, 99, 98 is not possible. That means low equals to mid plus 1. At last, return your answer. Right? Now, second thing, I forgot to write the base case. If my size of the array, that is number of books, is less than k, return minus 1 straight away. Then because first condition, that is each student should get at least one book, is not being cannot be followed. Now the check function, which is taking my array, taking my number of students, and taking my value which I have to check for. So I am at student number, let me write it, number 1. I'm allocating pages to student number 1. The pages he have in hand is 0. So for int I going from 0, I less than arr dot size I plus plus. If arr I is greater than mid, if the number of page in any particular book is exceeding the number of book, that is I have a book with 91 pages and my limit is 85, then it is nowhere possible, because I have to allocate this book to somewhere, and if we allocate to any student, 91 pages will exceed the limit of 85. I will have to return false here. That cannot be my answer. First thing. Second thing, if sum plus arri exceed mid, that means in the particular configuration, that is if the student has 46 pages and the limit is 90 and the current book has 67 pages, then he cannot get it, right? He has to change. That means my sum will be arri, that is student has been changed, that is number plus plus. Student has been changed. Else, if it is possible to add without exceeding the limit, without exceeding the 90 limit, right? So then just add sum plus equals to ARRI. Now, as I said, it is possible that I require a third student, but that is an assumption because I do not have the third student. So what will I say? If my number, that is my student ID, is less than equals to k, I can return true. That is, if I'm allocating allocating pages in less than required students, then I can reshuffle them. But if I'm taking more students, then I cannot reshuffle. Return false as well, right? Let us try to compile and run it. Hope it will work fine. Okay, there is an error. Sum was not declared. Okay, sum was not declared. It is pages. Pages here. Pages here. And pages here. Let us try it now. It is running fine for the sample test case. Let us try it for the hidden test cases as well. Getting accepted. So thank you for watching. Hope you liked it. Please make sure to like and subscribe to the channel. Thank you. Have a nice day.